So we're gonna start, I guess I'm gonna start the presentation now. So my name is Vladimir. I'm a customer success engineer here at OpenIO. And today I want to talk to you about our approach to monitoring at OpenIO. Now I know every company likes to do its own speech at how we do monitoring, stuff like that. Hopefully I'm going to explain through this presentation our needs, what we want to achieve long term, what we already have, and also show you, make a small demo of our monitoring system right now. Okay. So we're gonna start first with the way we think about monitoring and reporting in our company. Then I'm gonna speak about the implementation we decided to choose. It was a difficult choice. We had to go through several steps to achieve something we have, the thing we have today. Then we'll do the demo, and I'll speak a bit about the next steps and the roadmap and what's coming next in the next releases. So, design philosophy. So, for us, there are 3 steps at doing monitoring properly. So, first, it's a huge task, by the way. It involves a lot of man hours. It involves a lot of planning, what we're trying to collect, how we're trying to collect it. We're not here to do monitoring for generic systems, not only, at least. We're also trying to monitor our software in a way which allows us to detect efficiently and detect problems efficiently and outages, and predict and even be able to correct really quickly all the problems that could arise. So those 3 phases in the design of the monitoring are first of all collection and visibility. So first thing first, you just want to see what's on your cluster, right? You want to collect the metrics, you want to store them somewhere, you want to do some basic health checks, services up, down, and you want to see it all in action for small clusters and for multi-petabyte clusters as well, right? Second step would be to add more reactivity to this system, because here the thing is the user needs to be active in order to check every single day. So our support teams would check every single day if the platform is doing well, the cluster is doing well, all metrics are green, stuff like that. This is really tedious. This is not scalable with customers. So we want to add some layer of reactivity, which would require some advanced checks to be made. In order for the system to become more accurate, as well as implement a layer of alert generation, notification generation, and like notification basically sending to our users. And third step, which is I think what every single company who wants to monitoring wants to achieve, is intelligence and complete automation. So basically the cluster monitors itself, tries to repair some problems. For more complex problems, it identifies the cause, it searches for the solution in a known error database, it forwards everything to the system administrator or to our support teams, which then correct the outage. And it's also be able to monitor clusters which are at different locations, so have a global overview for multi-site deployments, and as well as provide some cluster optimization advice to their users. So the 5 goals we want to achieve for our monitoring system would be something like this. So system must be accurate. We need to measure precisely all aspects of storage, both coming from generic metrics and checks, which can come from the hardware and all layers, for example, smart matrix, I don't know, capacity, network bandwidth, etc., as well as from our own software. So OpenIO specific metrics, you've heard about the score, most of you, for example, but not only. We have event queues, we have to monitor them. We have Zookeeper instances running, we have to monitor them as well, etc., etc. So then the system must be meaningful, meaning that it's easy to associate something to symptoms. It's easy to associate a known cause, which represents something for the system administrators, so that they can easily comprehend, understand what's the fault about, and possibly think about how to correct it, or even just look it up in their database, right? Fault tolerant, if your monitoring dies, basically it's not good. I mean, you would need to detect it, that the monitoring is dead, because otherwise you lose your monitoring and everything is going to be fine, whereas your cluster is basically suffering or something. It must be scalable, because we don't want to have multiple implementation, one for small clusters, one for maybe bigger clusters. We want one thing that can work for small clusters, but also scale to multi-petabyte clusters, just as our customers scale our solution. And finally, it must be cost-effective, obviously. So yeah, if you need to more and more people as your cluster scales for monitoring, you're not doing right. You can do better. So our implementation. So this is what we went for. This is a generic diagram. Everyone does this, I believe. So we have multi-site infrastructure with here two sites represented. So at two different locations. Every site has an administration machine or a monitoring machine, as well as n nodes to monitor. So on each site, the admin machine will monitor the nodes. The nodes will monitor themselves as well for checks. And everything is going to can be stored locally on each site. And then you would have inter-site interaction in purple, which would give you a global overview of what's going on your whole cluster. So not only one site, multiple sites, right? Of course, it's not going to be the same level of metrics and stuff like that. So after struggling with other technologies, we tried many things. We tried graphite with diamonds, we tried InfluxDB, we tried a lot of things. And finally we went a non-creative way. I mean, everybody does that. So we said, okay, we're gonna test it as well, and this is Prometheus. So we went with Prometheus as well, right? So far, it's been 6 months since we've started testing it and implementing it, and so far we're really happy with what Prometheus does for us. So we reviewed our whole stack, which is comprised of Prometheus for metric storage, Grafana for obviously graphs, diagrams, I'll show you later. This is going to be in the demo. And for collectors, we're using both cost exporters for Prometheus, basically, as well as NetData, which is a software written in C, which allows plugins to be connected to it, which does really efficient monitoring of a lot of stuff already. And with the right plugins, which we developed in Golang mostly, we have a really efficient metric collection for both the system and OpenIO SDS, right? So I'm going to show you some screenshots, but this is going to be in the demo again. So Grafana would look something like this. You're going to have a view in real time. So this is what we're aiming for in terms of observability. We want something, we want one page, no scrolling, which shows us the most information it can of an OpenIO cluster, okay? So we have network data, both for taken by OpenIO SDS and the system. The system itself, is it behaving correctly? Do we have a full for storage, or do we have out of memory issues? Health data for alerts, ongoing alerts, stuff like that, and for OpenIO itself. So response time, global response time to requests, the score, events, stuff like that, as well as some data about what's stored on it. I mean, what's really stored on OpenIO. Okay. Then we would have something like this. This is Grafana again, another tab of it. So details of alerts, what service is malfunctioning, how many instances, what's happened, stuff like that, what checks failed, etc. Okay. And finally, we would like to have some alert notifications. This is not really well formatted, but here is an example of a mail received because a Redis service is malfunctioning. Okay. And here again, I don't know, for those of you who, I'll show the web UI again. We have a special tab in our web UI now, allowing you to consult alerts, and you're going to be notified in real time in the web UI as well. So it's time for the demo. So what we got here, we have three tabs. So first one is Grafana. Second one is the web UI. Third one is Mailhog. For those of you who don't know Mailhog, it's just a simple daemon which acts like an SMTP interceptor. So it can intercept SMTP messages, and it can show it to you as if you received an email. We're going to be using it for email notifications. So our cluster is right now 6 nodes. They're not really big. They have 47 gigs total, so it's a really small testing cluster. So they're already filled with system data because I decided to deploy SDS on the same partitions as our system, so it's fine. And what we're gonna do is, first of all, we're gonna see how the system reacts as soon as we start pushing something onto the cluster. And what we're gonna start pushing is the entire sources of U-boots. So around 260 megs, maybe more, of just .h and .c files. Via AWS CLI, so we're using the S3 gateway. So in production, you would have something like this. So this is the overview tab of the Grafana, which is standard installation for every single customer platform where we deliver monitoring. You have multiple tabs, but this is the tab you usually land on. This is the overview tab. You also have the health tab, which I'm going to show you later. And then you have the details about the system, the storage, the network, and the state of our services. So the overview tab is meant to provide a really quick overview of what's going on the platform, how much is stored, what happened, is everything behaving well, etc. So now, as you can see, things are evolving. So we're processing events per second, and we have stored already 136 megs of useful data on OpenIO, right? So clusters behaving correctly, so scores are getting lower because there's a lot of files being created and our testing machines are not that powerful, unfortunately. But so far so good, nothing has failed us. So we're generating bandwidth, stuff like that. No failed services, yeah. And here you can see a number of objects steadily rising as we push more and more files into, as we create more and more objects into OpenIO. So creating basically that's a lot of small files. So I'm not gonna go further into the process. It's just to show you how it can evolve with the time. So I'm gonna stop the process now. So now let's see what happens when something goes wrong. So what we're gonna do is we're gonna stop 3 Meta2 services. This will simulate some kind of an outage. Maybe your SSD or drive on which Meta2 services are deployed is dead. Maybe you have some kind of connectivity issues. Maybe someone has done something really nasty to those Meta2 services. I don't know. But here, as soon as we stop those services, we already have failed checks going on. If you look onto the WebUI, you have already those three services. Those 3 instances already are red, and we're gonna soon receive notifications into the WebUI of something going wrong. Here you can see it. Maybe you can't because it's in yellow. And if we click, we're gonna see that some alerts are gonna be created. So for now, they're unprocessed, but so we're using, as well as Prometheus, we're using Alert Manager as well. Alert Manager is a component which comes with Prometheus, which allows you to route alerts generated by Prometheus. So you're gonna route them to different receivers, and they have a lot of plugins available where you can send to notification by mail, Slack, webhooks, PagerDuty, whatever system you're using currently, right? So we have 4 active alerts, which all concern metadata stuff and Meta2 services. And here, as you can see, previously it was empty. We have 1 warning that something goes wrong, went wrong on a cluster, and that we have an SLA warning for metadata services because we have reached a critical amount, a critical limit for Meta2 services. So it's not a big deal on a huge, especially on a huge cluster, for 1 or 2 services to fail. It happens all the time. If you have, if you followed the case of Dailymotion this morning, there are 24 servers with 90 disks each. They have a lot of ROIC services, all right? So if 1 goes down, it's not a problem. Our cluster is still resilient. So we might not want to notify the administrator as soon as 1 instance goes down. However, if we reach a critical amount of services going down, which would create in turn errors in, for example, creating or reading objects, then we have to immediately notify users. And we're trying some things. It's not perfect, but we're on the point of designing a notification route system which will allow us to notify in the proper way our customers and our support teams, so that we can react quickly to any outages that happen on our cluster. So just to show you now, if we start those meta services again, everything's going to get back to normal. We're going to unlock them because, yeah. So it takes some time to go back to normal and for alerts to come down. So as you can see, no more failed checks. Everything is back to normal. We repaired the problem, and our cluster should become like blue. Everything is going to be fine again. So yeah, here. And our alerts are being resolved, and everything's back to normal. So there are 2 levels of activity here. First of all, we need to resolve critical outages. We need to be able to resolve critical outages and notify in time our support teams for our customers to have the less, for our support teams to be able to repair the cluster as soon as possible. And also to make sure that we keep the cluster in perfect health, or as much as we can, because in order to optimize performance for OpenIO itself, and yeah, it's basically better when everything is green. Okay, that's it for the demo. So just a small slide to conclude for the next steps. So as you have seen, this is the current release, the current state of the art. Here for the monitoring, so we have a fully working stack with Grafana, everything's provisioned, everything's really easy to install. We're using Ansible as well to install everything, so we have deployed last week or 2 weeks ago on something like 30 servers. It took us maybe 2 hours, not even 2 hours. Really easy to install, really easy to add a server. Everything gets monitored, and you have everything available as soon as it's installed, right? We are able to detect some basic outages, and we have basic like Web UI integration for service status, and as well as alerts. So now our short-term goals. So we would like to have more checks. We're not yet testing every single component, unfortunately. We would like to make some round-robin trips in order to see if an object is everything behaves well. We can create an object, we can delete it, we can create containers, stuff like that. With this, we would become more accurate in terms of monitoring. We'd like to monitor other stuff, for example, our file system connector, our high availability setups and stuff like that. And then we will be able basically to detect all basic outages that could happen, and have it reported as an alert or as an event to our system. And as a long-term goal, of course, we would like to implement a real known error database, which today is kind of available via our docs website as well as our internal knowledge, but we would like to consolidate it into one single big known error database, and be able to use it in order to suggest cluster optimization and repair options, as well as maybe auto repair trivial problems if the customer wants to do so, and try to combine different causes in order to determine more complex problems. We've had problems which cannot be resolved by just saying, okay, this is one service, it's down. There are way more complex stuff going on. Sometimes it might even lead to a bug into the software. It happens. Hopefully it doesn't happen often, but it does happen. So we would like to really analyze and be really precise about how we do monitoring. So, do you have any questions?